So go ahead, let's talk about Tukey's test for Anova. Don't run this with the Krzyzewski-Wallace test. You can't do it because it's a different test. This is only for Anova when we're looking at means. So the Tukey's post hoc test will explore the differences in the groups after an Anova test. This test makes comparison among the groups to see if the group's means are different from one another using 95% confidence intervals. If the confidence interval range doesn't include 0, the differences between the means is statistically significant. All right, so what we're doing is we've run the Anova, and remember, Anova compares 3 or more groups by their means. So we can either say that all the means are the same or at least one mean is different. So when we say at least one mean is different, Tukey's test goes and finds where the differences are so we don't have to run t-test or two-paired t-test. This does it for us, and it's really convenient. So let's say we have 3 groups. So then the Tukey's test is going to compare between the mean of group 1 compared to the mean of group 2, the mean of group 1 compared to the mean of group 3, and the mean of group 2 compared to the mean of group 3. So let's do an example. A chemical engineer wants to compare the hardness of 4 blends of paint. 6 samples of each paint blended were applied to a piece of metal. The pieces of metal were cured. Then each sample was measured for hardness. If you know where Volstapine, or I always say it wrong, Volstapine, I think it's off Castaway Road in Bartow County, they have something like they do this in their labs. They test metal components and they cut it down into itty bitty pieces, and then they do chemical tests on it. So this is something you would see in industry. So at the 5% level of significance, is there a difference in the hardness for the 4 blends of paints? Okay. Again, I've got 4 groups, and the 4 groups are the 4 blends of paint, and I want to see the average hardness for each group to see if it's different. So again, we're going to import the data. So I'm going to flip here, and let me do this. Let me close out of here, and I'm going to open it up new. Okay, I have downloaded this to my computer. I've got it as an Excel or a mini tab. Again, I'm lazy. I'm going to open it as mini tab because for me it's so much easier. It just opens right with the way I need it. Okay, so I did that, and look, it gave me it gave me paint, hardness, temperature, and operator. So I'm going to go to stats. I'm going to go to Anova, and I'm going to go to one-way Anova. So because everything is in one column, I'm going to pick my response, which is hardness, and my factor, which is paint. I'm going to go to options, and I'm going to do assume equal variances, 95%, and it's a 2-sided. And then now I'm going to go to comparison, and I'm just going to click on Tukey's test. I hit OK, and I hit OK. Okay, so it's going to start giving me everything. First thing I get are my means, or my null and my alternative. My null is all the means are equal. The alternative is none of the means are equal. Not all means are equal. So let me go back to my PowerPoint. I had those on there. Yeah, so here we go. I have them on here. I wrote them slightly different. I said my null was the average hardness for the paints are the same, and for the alternative is the average hardness of the paints are not the same. So again, you can write these like in mini tab, but I would put what the means are. Like all means of the paint hardness are equal, all means of the 4 groups of paint hardness are equal. Something like that. Make it where I can understand that you know what I'm talking about, not just this wording, okay? Okay, so I've got that. Oops. Keep going. It gives me my factor level. Remember, factor in this one is blend 1, blend 2, blend 3, and blend 4. It tells you what your factors are. Say like we had 20,000 different kinds of paint, and I wanted to know what my groups were. Basically, my categories, that's what that does for me. It runs my analysis of variance, which gives me my F value and my P value. It gives me my R squared. So remember, go back and look at that when we talked about it in the original Anova. And then it gives me my means for each blend. It gives me sample size, mean, standard deviation, and the confidence interval. Okay. Okay, and that confidence interval is different from Tukey's. All right, so let me keep going. All right, so let me go flip back here. I have all the directions here, so it should be pretty easy. And then, okay, so I've got everything. All right, so, all right, if I look at, and this one now is at the bottom of this, the comparisons of the mean together is at the bottom. But if I look at it, I can see something's going on with blend 2 and potentially blend 4, but I know blend 2, there's something different. So then if I look at my conclusion, I say, since we concluded our hypothesis, we can compare our p-value to our level of significance. So our p-value of 0.004 is less than or equal to 0.050. So I'm going to reject the null. So that means the average hardness for the paints are not the same as correct. So my conclusion is at the 5% level of significance, there are differences in the hardness of the 4 blends of paints. We can conclude that at least one blend is different. So a Tukey's test helps us determine which one it is. All right, so let's go look at it. So I put it on the sheet just to make sure. All right, so and again, it's if I scroll up, they do use this comparison, and it's kind of confusing to me. So let's look at here. So here's this graph, and I put it on the PowerPoint to make it interesting. And let's do current slide. All right, so again, if an interval does not contain 0, the corresponding means are significantly different. This one contains 0, this one, this one, this one, and this one. This one does not. So what that means is I can see that blend 4 and blend 2 have significantly different means since the confidence interval does not include 0. Since blend 2 and 4 have significant means, the Anova found that there were differences in the mean, and the reason it rejected the null is because of this right here, the mean comparison of blend 4 and blend 2. Because remember, we're not looking at just one individual mean, we're looking at the relationship between the mean.